Alan here, another video update on the project to replace the brushless linear DC motor with a AC inverter duty motor and Hitachi sensorless vector drive inverter. So I've been working on the project, made some progress here, and thought I'd share the progress with you guys. So this is the VFD. I've got it all wired up and under mock control, and I'll just talk about how I did that. Basically these gray wires coming in, you can see there's two sets of wires. They're basically two pair each, shielded cables. Usually use these for like wiring up home switches or whatever. I'm using them to go between the C23 breakout board and the VFD here. Basically you need 5 wires to wire it all up, and since I didn't have any 5 wire shielded, I had to use 2 4 wire shielded cables. So I just ran those through the bottom of the machine here and basically out to here, and basically so the bottom set of wires, this set of wires here is carrying the 12 volt signal. So the red is positive 12 volts, the black is negative 12 volts. That's coming off the C23 breakout board, the analog speed controller. So there's 12 volts on the back. That's a power supply, 12 volt power supply that feeds into the breakout board, and it spins out 0 to 10 volts to these 2 wires here, and they're wired up to O terminal and L terminal. So the O terminal is plus 10 volts and the L terminal is common, okay, or the ground if you will. And so basically the 0 to 10 volt signal is going to come in there, and that's going to determine the speed or actually the hertz, the frequency going into the VFD corresponds to the voltage. So from 0 volts being no speed all the way up to 10 volts being 120 hertz. And then this top wire here, this wire number 2, is the logic. Okay, so P24 there on the VFD is plus 24 volts coming out of the VFD. So the VFD supplies 24 volts for logic signals going in. So you basically run that 24 volts to the voltage in on the relay, and then you run the normally open leg of the relay back to these programmable inputs, and pin 1 here and pin 2 are programmable inputs, and you can program them to whatever you want. I've programmed them to be forward run, stop, and forward run, stop, and reverse run, stop. So that's how that works. So you get 24 volts goes out, goes into the voltage input on the relay, and then normally open leg goes to from the 2 relays on the C23 goes to pin 1 and 2 on the VFD. Then you go in, you program them, you say this is and the way you do that is you hit the escape button here till you go to the C codes. C001 defines what pin 1 is. If we do set there, it's 00, which defines it as forward run and forward run stop. Okay, C002 is pin 2. Set there, 01 is reverse run stop. So that's how you define those programmable inputs. Okay, so all right, let's go look at the breakout board side of it. So on the breakout board side here, we got our two solid state relays with those little blue boxes up there, and then the inputs for those are the screw terminals up top there. So the 3 over here are the 3 screw terminals. There are the relay that goes to pin 1 on the outputs, and then the 3 right there are pin 16 on the parallel port outputs. Okay, so you can see pin 1, the white wire, which goes to pin 1 on the VFD, and then I jumpered over the 24 volts voltage in, so the red goes into the voltage in on that relay, and then jumpers over to the voltage in on the second relay. And then the white wire, which is going to pin 1 on the VFD, is wired to the normally open leg of the relay. Okay, the green wire, which is going to pin 2 on the VFD, is going to the normally open leg of the second relay. Okay, now the plus the 10 volts is coming from right there. So that black and red pair right there is the 10 volts, 0 to 10 volts coming out. That potentiometer right there is how you adjust the maximum voltage coming out of there to make sure it's 10 volts basically. So you turn your spindle to full on all the way up 120 hertz and measure the voltage on those 2 pins, and it should be 10 volts. You adjust the potentiometer to make sure you're getting 10 volts. Now these, I don't know if you can see very well here, there's some stuff in the way, but so the too many wires here. Basically back there, that's 12 volts in, so that's the red and black there is 12 volts in that powers that the DC analog motor controller, speed controller basically. So 12 volts in, that's being powered by this little 12 volt power supply here. Okay, so the 12 volt power supply goes over, follow the wires over, goes into that terminal strip, and then 12 volts comes out, goes into the 12 volts in for the. Now this 12 volts has to be separate from all your other signaling, all your other inputs and outputs. So it can't be sharing common ground for it to be optically isolated. You can't be sharing common ground with this and any of your other signaling going on. So this is just for that, and then the relays. And that's really all there is to it. It's pretty straightforward. Now, what was confusing about it, I'll show you what was confusing about it. It's the Mach 3 side of things. So, in Mach 3, go to config here. We're going to go to, try and get rid of some of that glare. Go to ports and pins, and so we're going to go to motor outputs. So the spindle is enabled. Pin 14 on the breakout board is going to output your signal that's going to generate your analog voltage from 0 to 10 volts. So that's your step pin, pin 14. Now it's also got a direction pin, and what's confusing about this is we're not actually using that direction pin because we're going to use the relays to determine start, stop, forward, reverse. So we're not actually using that direction pin. What's kind of annoying is you can't define that as like 0. I tried. If you define it as 0, the smooth stepper gets all bent out of shape. It's actually smart enough to know that's an invalid input, and it'll throw a warning and won't run if you give it an input of like 0 or. So right now I've set it to output 9, and output 9 is not currently in use. But basically I'm wasting output 9 because the smooth stepper is smart enough to not allow me to do that. And what's confusing is when you're looking at this, you're thinking step and direction, and you're thinking, well, then this should control, this should control the direction, but it doesn't work that way. The relays control the direction. So ignore, the direction is basically, you see, if you can set it to 0, if not, set it to an output that's not in use because it's not going to be doing anything. So step port and direction port are 1 and 1. Directions low active and step low active are disabled, and that's really all there is to that. Then the next thing you have to do is going into the spindle setup. Basically you're going to use spindle motor output, step direction motor, even though we're really only using step, we're not doing step direction. We're going to define it as step direction. Okay, and so on the outputs, we're using output number 1 and output number 2. Now what's confusing about this part is these outputs are not pin numbers, they're output number, they correspond to outputs that you've defined. So output number 1 is not necessarily pin 1 and output number 2 is not pin 2. Output number 1 and output number 2 are the outputs that you define under output signals. So you go to output signals, you can see here that we've defined output number 1 and output number 2 are enabled. They're both on port 1. 1 is pin 1, which corresponds to that forward relay, and output 2 corresponds to pin 16, which is that reverse relay. Okay, so that's our 2 relays, and then we take these output 1 and 2 that we've just defined here, and then under spindle setup we set those as output number 1 and 2. That's going to control clockwise and counterclockwise enable for our spindle. Okay, so that's how we're going to start and stop the spindle. I've set my dwell parameters here for 4 seconds, and that matches what I've set for my X cell and D cell in the VFD. At first I had my D cell set to 2 seconds in the VFD, and that was causing E72 overcurrent condition, as it was just trying to slow down too fast. So I had to change it to 4. I might be able to get away with 3-second deceleration, but I didn't want to chance it, so I just set it to nice safe 4, and that seems to work fine. So another thing is in this side of it, so you have your motor tuning parameters for the spindle, right? So we go to spindle here. You're going to set this to 1,000 steps per. That's just kind of a default value, and I messed around with it, and you do want it to be 1,000 steps per. Set the velocity to maximum. Acceleration start with 450. You can play around with other parameters later. I set mine to 450. I haven't changed it. It seems to work fine. Now these step pulses and direction pulses, you're going to want this to be your step pulse is going to be a 2 microsecond pulse. Okay, and then say OK there. Now one other thing is, because I'm using the smooth stepper has its own settings, so we have to go into the smooth stepper window here. And in the smooth stepper window, you have your spindle control here. You've got relay or none, pulse width modulation, or step and direction. I'm using, we're obviously using step and direction, and then I set my microsecond pulse width to 2.2. The reason I did 2.2 is that that 2 microsecond value is irrelevant to the actual way it works for the smooth stepper. The smooth stepper is actually using this value, and that 2.2 microsecond pulse width was giving me speeds that matched, basically. So what you're doing is you're taking that 0 to 10 volts and you're trying to map it, to frequencies on the VFD, and I found that this 2.2 microsecond pulse was giving me speeds that matched more closely. So when I would say 1,000 RPM, I was getting closer to 1,000 RPM by changing this value. So if you change this value higher, so if you change this to 3, it actually makes the motor run faster. Okay, so started off at 2, did some tinkering, found out that 2.2 gave me the most accurate speed matches between the voltage value and the frequency value on the VFD. And I spent a lot of time tinkering with, trying to get the voltage value to correspond to the input or the frequency on the VFD. And there's a bunch of VFD settings I had to think with in terms of, and I'll document that at some point, but in terms of, like what corresponds to what's the maximum frequency, what's the minimum frequency. So I've got the maximum frequency set to 120 hertz because that's the maximum for the motor. And the minimum frequency I've got to set to 6 hertz. Now the minimum frequency for the motor is 4 hertz. But the reason why I set it to 6 hertz is if you read in the manual, it says that it delivers maximum torque at 6 hertz. Okay, and I want to deliver maximum torque through all my speed ranges. So it delivers the full torque available to the motor at 6 hertz. So that's my minimum. Maximum is 120. The minimum starting voltage is set to 1.3 or 1.4%, which corresponds to 1.3 to 1.4 volts. So what happens is when you just turn everything on, basically you're going to get a value. You're not going to get a perfectly 0 volts value from the speed controller. You're going to get some value like 1 volts or something like that. and that's going to be the slowest speed. In my case, I think it was 1.3 or 1.4 volts. So I set that as it's actually in percentage, but in this case 1.3% actually corresponds to 1.4 volts given it's 0 to 10 volts. And that probably doesn't make any sense, but at any rate, it's set to 1.3 or 1.4%, something like that, for the minimum starting voltage. Okay, so let's just walk through and I'll show you how it works. So spindle speed, we'll set it to the lowest spindle speed based on the 6 Hertz value and the pulley setup, which is a 1.5 ratio. It gives me the lowest spindle speed of 270. Okay, that's my minimum spindle speed. Okay, so I'll go ahead and crank it on here. Okay, so it fires right up, and if I want to see the frequency coming into my VFD here, I just go to the D values, which the D values are your displays. D01 is your frequency. So you can see there it's fluctuating a little bit, but it's basically 6 Hertz is what's going in for my low value. So that is the slowest speed that the VFD and motor will deliver its maximum available torque, which is 270, RPM in this case. And one thing is, like in terms of the speed matches on this stuff, it's pretty good, but you're taking a voltage and you're trying to turn that voltage into frequency, and there's some compromises basically. If you tune it perfectly on one end, it's going to be a little off on the other end, so you kind of have to tune it for the middle. So the base frequency of the motor is 60 Hertz, right? Being an AC motor, okay? So what that works out to be is like 1800 RPM is the base speed of the motor, okay? And with the 1.5 ratio, that's 2700 RPM is the base frequency setup. So I kind of tuned it around that to have that be as close to accurate speed as possible with any compromises on either end of the scale. So let me go ahead and stop this. And I'll show you kind of. I also did some, kind of touch points along the way of, like 1000 RPM and 4500 RPM and then max speed and all that, just to kind of, see if I can get it as close as I can. But again, it's a series of compromises. So this is 1000 RPM, or should be 1000 RPM, and let's see, yeah, so it's about 900 and some change. It's as close as I could get it. And you'll see on the high end it's actually a little too high. So like 4500 RPM is actually 4800 RPM. And like I said, it's kind of a series of compromises to get it right, with taking that 0 to 10 volts and mapping it to actual speeds or what have you. So let me do 2700. This is base speed of the motor here, and you can see, down here on the frequency counter, we're getting like 58, 59 volt or hertz, basically. And then so on our RPM photo tack here, we're getting like 2600 RPM or so. Okay. And the spindle sounds really nice, actually. I'm really happy with how everything's working so far. And so this is going to be max speed here. So double the base frequency, 120 Hertz. This gets loud, and so you can see there, max speed 5400 RPM. So that's where it was getting the E72 error, was on decel from 5400 RPM. It was sending current back through the line, I guess. I was trying to decel it in 2 seconds, and I guess that was just too much for it. So I messed around a little bit with DC braking, and I decided that I didn't really need DC braking. I'm just using the Excel decel parameters. There's a lot more to setting up the VFD. There's a lot of settings overall that I had to play with to get everything set up. I'm going to try and go back and document all of that, but that's going to be a process. So I'm not even sure I remember everything I've changed at this point. But yeah, there's a couple key things I'll make another video on that. If you know a few things, it's pretty straightforward, and you can just kind of play around with the parameters and set it up how it suits you. So kind of the next step now in the project is to mount the VFD, mount the fusible disconnect, clean up the wiring, get it all kind of permanently set up and buttoned up. I've got another relay coming for the flood coolant, get the flood coolant wired up, get the lamp wired up, get the pendant wired up, just get everything buttoned up, and it's good to go basically, and then I can start doing some test cuts and whatnot. I think that's it for now. This is a long video already, but yeah, it's getting there, and everything seems to be working just as I planned, which is always nice and kind of surprising, to be honest with you. You always expect to run into some major issues, but yeah, everything seems to be working out just fine. So more later. Thanks for watching, guys.